some amazing weather science this week and this last week too. My name is Dr. Erica. I am so excited that you are joining us. And just a reminder, if you want to do lots of fun science, make sure you subscribe to our YouTube channel. You can check us out on Facebook, and you can always support us at patreon.com/rosieresearch. And this is our last day where we are learning and doing experiments with weather science, because tomorrow we are taking a virtual field trip to the National Weather Center where we're going to watch all about the National Weather Center. We have Caitlin who's going to take us on a tour through the center, and she'll be there after the tour to show us some pictures of her in action learning about weather stuff when she was in college, and also just to answer questions that we may have. So I'm really excited about that. You got to make sure that you tune into our Zoom tomorrow at 1 o'clock if you want to come join us for the National Weather Center. And today I wanted to show you guys just how strong air can be. And not even necessarily like windy air, but just how strong air itself that we're sitting here with can be. And the way we're going to do that is we are going to create, again, a high pressure area of air, which is really warm air, or sorry, a low pressure area of air, which is really warm air. It's not very dense. Hot air rises. And then we're going to use high pressure air, which doesn't feel very high pressure because it's the air we're sitting in right now. So it's stuff we're surrounded by. And we're going to use that to push this egg into the bottle. I'm a little embarrassed to say, I loved this trick when I was a kid, and I haven't actually done it with my children until like 2 days ago when I bought the gorgeous chocolate milk that we are using this gloss bottle for, and they got to see it and they were like, what is going on? I was like, I have failed you, my lovelies, because they're in 1st and 5th grade and they haven't seen this experiment. And if you're in the same boat, I'm happy to say that you'll get to see it today. Now, traditionally, the way we heat up the air inside the bottle, because what we're going to do is we're going to make it so there's not as much air inside the bottle, and we'll do that by heating it up. And all the air molecules are going to get hot, and when they get hot, they start to jiggle, and then they have extra energy, and they got to run around. Just how when you have extra energy, you really want to first you start bouncing around in your chair, and you can't get enough, and then you get more energy, and you're like, oh, I got to go outside, and you got to run around the house, right? Same thing happens with those molecules. Right now, they're just hanging out. And we're going to warm them up, and they're going to start to they're going to get a little jittery, and as we add more energy, they're going to bounce around, and as they run around in this bottle, some of them are going to start to come out of the bottle. So there's going to be fewer molecules of air inside the bottle than normal, than what's outside the bottle. And what's going to happen is as we heat up the air, the hot air rises, and then we'll put the egg on top, which will create a nice seal. So if you don't have an egg, you really want something that'll create a nice seal. Maybe like a soft, bouncy type of a ball, like a squishy ball, or some slime could work for this, which would be really fun. But anything that's going to make a really good seal here. Because what's going to happen is as the air inside cools, it used to be running around and really happy. As it cools, it's going to start to settle down again. And it's going to realize that, wait a second, the air out here, which was settled the whole time, has more molecules outside in this area than there is inside. And those molecules, they can all push on that egg, and the ones trying to push out from the inside there's not enough of them. They're not as strong. It'd be like a tug of war with 1 molecule versus 10 molecules. There's the 1 molecule inside and the 10 outside, so they get to push the egg in, which is really cool. Now, traditionally, this experiment you can do with fire. So you could light a piece of cardboard on fire, and you can put it inside of your bottle, and that will heat up your air really well. But I also know that right now, a lot of you guys are learning independently, and your parents are probably like, no fire, not cool with fire. Because I wouldn't feel super comfortable with kids just playing with fire while I wasn't there. So if you have a hair dryer, you can go and grab that hair dryer, and we can use that to heat up the air inside the bottle. Now, unlike most American families, we don't have a hair dryer, but we do have a heat gun. It's very likely you have a hair dryer, but don't have a heat gun, because this is like a science nerdy thing. But they will work the same way. They will both heat up the air inside, so you'll still be able to see what happens. And all we need to do for this experiment is to heat up that air inside. If you don't have a hair dryer or a heat gun or fire, another way you could do this is get a pot of boiling water and put it in the pot of water. So not water inside, just put it inside the pot of water, and it will start to heat up the air inside. That will work also. So any way you can think of to heat up the air inside, and then we'll seal it, and the air outside will push our egg in.
All right, so it's gonna get loud, but I'm gonna heat up the air inside by just blowing warm air in for a little bit. I wanna make sure the glass feels kind of warm. So if you're doing this with a hairdryer, you're gonna do it until it feels pretty warm. All right. Ooh. I like that sound. Turn it off and you can put your finger in and check. It's a little warm in there. I'm gonna add a little bit more. I'm gonna keep going. I wanna make sure it feels really warm all the way. So I have lots of air molecules jiggling around and getting out of there so that I'll have more pressure on the outside to push that egg in. But it does make a cool sound. Do is put my egg on top and we're gonna wait. Now right now doesn't look like it's gonna do much, but as the air inside cools, my egg is gonna start to get into this bottle, which will be really fun. This experiment takes a little bit of time and a lot of patience though, and if you overboil your egg, sometimes it won't quite go all the way in. It might get stuck part of the way. So a great thing to do is to observe it as it's happening, because if it doesn't go all the way in, then you can still see as it starts to get sucked in. In fact, the first egg that we did, I boiled it and kind of forgot about it and boiled it some more. It was a very hard egg. I mean, this was like a bouncy ball type egg. And it didn't get all the way through, but when I tried to take it out, it was really cool because you could hear this, and you could hear it, the seal go, and you could hear it suck in that change in air pressure between the two, which is really cool. So as this cools on down, we will see it get sucked into that jar. And we could always also try with a match if this guy doesn't work. Ooh, Evan's getting, I think, some ice packs. Maybe he's like, let's speed it up. I think he's trying to speed it up. He's gonna get us an ice pack and ice water, which is a great idea. And I love that he's thinking about, ooh, how could I make this reaction go faster? And one of the ideas would be to do an ice pack, and the other idea is to make the air inside hotter with maybe like a flame, because the flame is much hotter than what this guy is. But it is starting to go a little bit, and I think it's feeling a little warm here, although the bottom of my thing doesn't feel warm. So we might take our egg out and go with fire, but
well, they've seen the example of how they would heat that.
Yes, this is how you would heat it up, and Evan is thinking, which I love, we're gonna try it. If we put it in cold water at the bottom, will that help it get sucked in faster? Because it's gonna cool the air inside the jar even faster than when it's cooling now, which is really important. Because this guy takes a little bit of time. Sometimes that's hard about doing science live on YouTube, but you can always just skip forward.
But we can ask if any of our viewers have National Science Weather Center questions.
Yes, if you have questions for the National Weather Center, I can send them to Caitlin tonight, which will be awesome. I'm gonna put this colder water up here too. I think my hottest air was really up here because that was closer to where the hairdryer was, which is cool. But I do see it going in some. It's slowly creeping in. That air is doing its job, the air pressure, which is amazing because this is the air that's on your body right now. In fact, it's holding your body together. All right, so if you went out to space, we have to wear special suits. We don't just like pop out into space just because. And that's not only because there's no oxygen in space. Space is a vacuum, so it's true there's no oxygen. Really important. Oxygen's really important to breathing. There it goes. Look at that. It went all the way in, which is super cool, and now it probably won't come up, which is amazing. Now, you might devise an experiment to try to get it to come out, which could be really cool. I want to see what you guys think that you could do. I have an idea that I think might work, and maybe we'll do this in Zoom because I do not want to ruin it for anybody who watches it on YouTube later. But I'm curious if you could think of a way to make this guy now come back out of your jar, which would be kind of a fun project too. So you can definitely do it with a hairdryer. If you want it to go a little bit faster, you could do it with a match. That one, you sort of see it pop in a little bit faster, but not a whole lot. But this is the air pressure, and this is what's creating the winds that we see. It's what's pushing the clouds in the sky, and what's holding our bodies together. Because again, we do need the oxygen in space, but also if we were in a vacuum, there's nothing to hold our skin and our bodies together because there's air pressure acting this way on my skin and this way and that way, and it's all pushing in on me. It's all keeping me together. I'm really thankful I have air pressure to keep me together and not just sort of boil off away, because that would be a terrible way to go. And this is a great way to see how strong that air pressure is. We didn't even change the temperature that much, right? This was a slight change in temperature, and the outside air was able to push that egg into the bottle, which is super cool. All right, well, this is a fun, fast experiment. If you're on YouTube and you're thinking of a way that you might be able to get that egg back out in one whole piece without cheating and pulling it out yourself somehow, only using air pressure, I would love for you to type that in the comments. And if you have an idea and you're coming over to our Zoom room, we can talk about it and we can even try it together. All right, it was awesome doing science with you guys today. I'm gonna go check out our Zoom room and hang out. We hope to see you there. And tomorrow we're going to see you as we visit the National Weather Center. We'll be in our Zoom room if you want to do that, and we'll have Caitlin there to answer any questions you might have. All right, friends, we'll see you soon.